We'll get started. It's 12 o'clock. Welcome to today's Roads to Research session. Thank you to everyone who's joining us live. Before we start, I just want to take a moment to acknowledge that Royal Roads rests upon the ancestral lands of the Coast-Sampson and Lekwungen nations. And I'm speaking today from Lekwungen Nation territory. And I invite each of you to take a moment to think about the land on which you're living and working and to acknowledge the original people of that territory. Today, we're very pleased to welcome Dr. Hany Fahmy, Associate Professor and Finance Intellectual Lead in RRU School of Business. His presentation, How is a Pandemic Changing Our Reality? The Social, Economic, and Financial Implications of COVID-19. We're recording this presentation for social media. There'll be time throughout and at the end for questions. And finally, we thank the Canadian Tri-Agency Research Support Fund for their support of these events. Over to you, Hany.
Thank you. Well, thank you, Vanessa, and thank you guys for joining. So today I'm gonna talk about what's happening, and how this major event is changing our lives. I'm gonna start by sharing a file with all of you. So I know that we are doing this online rather than face-to-face. So, however, if you have a question or if you have a comment, please raise your hand. There's an icon at the bottom of your screen, and I will stop and take your question or your comment. I think that would be a better way of doing this rather than just reserving 10-15 minutes toward the end of the session for questions and answers. So during my presentation, feel free to interrupt me at any point, and please raise your hand if you have a comment. Again, the idea is to actually encourage everyone to comment on this, because it's a research project. I have a paper already that I will submit within a week or so on the financial implication of the COVID-19. But regarding all the other aspects, what I'm doing right now is just raising interest in the topic, and I would like to see or hear your comments about it. So feel free to stop me at any time. So here's the motivation. What we're going to assume, I'm going to start by assuming that we have two states. So just to keep it simple, right? We can generalize this to many states. S would be the pre-pandemic state, which is before what happened. And S prime is the post-pandemic state. This is what we are living in right now. The key idea actually is to consider the consumption or investment or any activity rather than consuming a particular good. We are consuming we are executing an activity. An activity is a combination of a vector of goods, which I'm going to call Y, and the duration time. This vector Y consists of a number of physical goods, and T is the duration time of the activity. So you can think about your daily activities. For example, running is an activity. It will consist of the running gear, which a bunch of goods that you use, physical goods that you consume, and the activity time, the duration time, your running time. Watching a play is an activity. It consists of, again, a number of goods, the theater, the equipment, the chairs, whatever you're consuming. It's a vector of goods and the duration time of the play. Sleeping is an activity. Working is an activity. So think about, when you think about this setup that I'm about to introduce, we're considering a utility or the amount of satisfaction that we derive from consuming activities rather than consuming goods per se. So the traditional or the classical treatment of the utility theory or the choice theory is that the amount of satisfaction or utility is usually derived from I'm sharing the video too, sorry. The amount of satisfaction or utility is usually derived from goods rather than activities. So what I did is that I I added a dimension, which is the time dimension. So before, time dimension didn't exist in choice theory. So we usually model consumption or investment of physical goods. But now we are thinking about it as a combination of goods and duration time. So what I want you to think right now, think of an activity that you used to execute in a certain way before, in state S, before COVID-19, and now you are doing it or executing it in a different way. Actually, this presentation right now is a key in point. We used to have those presentation face-to-face. So that's how the presentation is an activity to start with. It's a combination of, laptop, your equipment, physical goods, and the duration time, the 1 hour. So we used to do this face-to-face. That's in state S. In state S prime, it is done now online. Is this change good or bad? Is this change efficient or not? Would you rather go back to state S or stay in state S prime and improve it? So those are the questions that we will answer, or we're trying to answer in this presentation. And again, as I said, think about activities as a combination of physical goods and the duration time of it. I'm sure that many of you have, you were executing activities in different ways before, and now you're doing the same activity but in a different way. So I'm going to start with some notions. I'm going to start with, we're going to use functions. So a function is a map. When you say a utility function U, it's a way of transporting, or the transportation device that move from one set to another set. So usually when you say a function, it's just a way of transporting or moving from a set, we call it the domain of the function, to the codomain of this function. In choice theory, which I will be focusing on because I'm extending it, the set that we are interested in, we call it L, is a set of choice. Sometimes we call it the set of prospects. In this set, you will have the vector Y. So this is the set that contains the set of goods that you are about to consume. So if you can prove, or you can show that there is a utility function, then you have a map or a device that basically moves you from the set of choice, the number of goods, to a value. So when you say the amount of satisfaction that you consume from good X, or the bundle X or the bundle Y, it's let's say 10 utiles or 15 utiles. This is a measure of satisfaction or utility from consumption. Okay. Remember, Y here is a bunch of goods. So Y is an alternative or a bundle that consists of n goods, a number of goods. So if you take a two-dimension, just a simple example. So we have two goods only. So for example, here I have X1 and X2. So this is my set L. It's just a set in two-dimension. So when I say the bundle Y here, it means it consists of 0 unit of good X1 and 1 unit of good X2. So this is just an alternative or a bundle. And if you apply the utility function to it, then you can get the utility from that particular bundle. Y prime is a bundle that has 1 unit of good X1 and 1 unit of good X2, and then there is a utility from it. I'm going to call it Y prime. When we model choice relations, we have a preference. So consumers, remember, in this case, I'm ignoring completely the time dimension. I'm just focusing, reviewing, or giving you the idea of the choice theory. So again, you have choice from bundles of goods. And what you do is that you can sort those bundles or those relations according to a preference relation. A preference relation is a way of saying that bundle Y, if you prefer Y to Y prime, then you can say Y is strictly preferred. This is not greater than or equal. This is, there is a curl in there. So this is just a symbol that represents a relation. So those are symbols that we use to present a relation between two alternatives. So when you say Y and you write Y, strictly preferred to Y prime, it means that you prefer this alternative to, strictly prefer this alternative to the other one. If you use this additional symbol there, it means that Y is at least as good as Y prime to you. So it's a way of modeling your preference over different bundles of goods. The rational choice theory is basically assume the setup, and we are talking about relations. For a relation to exist, if you want to compare alternative, you need three assumptions. Those assumptions are borrowed from mathematics. The first assumption is called completeness. So if you want to, basically, if you want to say this relation, there exists a relation and this relation is complete, it means that you can either, if you have two bundles, for any two bundles y and y prime in the set of choice, y prime could be strictly preferred to y, or y be strictly preferred to y prime, or you could be indifferent. This sign, this symbol here means that y is indifferent to y prime. So if you think about the relation, any relation, for example, your student in your class, if you want to compare the height of two students, you can say this student is taller than the first, or the second is taller than, the first is taller than the second, or the second is taller than the first, or they could be of equal height. So this means that the relation is complete. Transitivity is another assumption. So if you have three bundles, y, y prime, and y double prime in the set of choice, then if y is strictly preferred to y prime, and y prime is strictly preferred to y double prime, then the transitivity implies that y has to be strictly preferred to y double prime. So this is another way of ordering alternatives. So together, completeness, transitivity, and continuity, if you assume continuity, this is a assumption. Again, I'm not going to go over the math about the technicality of this. I'm just giving you the idea. So if you assume completeness, transitivity, and continuity of preference, then we have a relation. So this means that there exists a particular order over the set L, the set of goods. So your preference, you have to order things according to your own preference. Each individual has a preference. Each individual has a specific order. Okay. Now, Gerard de Broglie in 1954, and that was a major contribution, showed that there exists or the existence of a utility representation of a preference relation that preserve the order. This is a major or a main theorem in consumer choice theory. And by de Broglie's paper, or by de Broglie's theorem, basically we can say the following. If I have alternative y, or a bundle y, that I prefer strictly to bundle y prime, then this implies that there exists a function, a utility function, such that the amount of satisfaction, or the utility from this alternative, is strictly greater than the amount of satisfaction from alternative y prime. This line here is actually is four-page proof, and it's a major fundamental result in choice theory. Why? Because it allows us to move from preference relations that we are just qualitative to numbers, to quantitative. So here we are saying that just alternative y is preferred to alternative y prime, but by the Broglie theorem, we can actually measure it. We can say that the amount of satisfaction from this alternative is strictly greater than the amount of satisfaction from y prime. And u here is being the map, or the function that I'm talking about. So basically, this map, or this utility function, transports you from the set of goods to the real line. The real line, when you say utility of y is 20 utile, it means that you can give it some a value, a numerical value. The problem with this representation, though, it's Gerard de Broglie showed in 1954 that this function exists, but it doesn't have a unique definition. So this function exists, but it is not unique. There are so many definitions of it. The standard treatment, if you took a course in economics, it's called Cobb-Douglas utility function. This is the nice, well-behaved utility function that we would like to see that represent this preference relation. But any other function could do with some restrictions. Again, we're not going to talk about that, but at least you understand that the utility function moves you from a qualitative presentation like that to a quantitative one. So for example, I give you a function like this. The utility, in this case, I'm assuming the utility is the product of two goods, x1 and x2. And I'm considering the bundle y where you consume 0 and 0 units, right? So the amount of satisfaction from y, according to this definition, is 0 multiplied by 0, which is 0 utiles. So now I gave it a numerical value. And then there is a bundle y prime, which is 1 unit of x1 and 1 unit of x2. So this is y prime there. And the amount of satisfaction, if you plug those values in the utility function according to this definition, then you get 1. Obviously, 1 is greater than 0. So you can say if you prefer y prime to y, then the amount of satisfaction that you get here is greater than that. That's the idea of moving from qualitative preference ordering to a quantitative utility representation. Your objective as a consumer is to maximize, according to the rational choice theory, is to maximize the satisfaction from consumption of goods. So you want to, it's an optimization, you want to reach the maximum or utility subject to certain constraint. This is the standard classical treatment of utility. Notice here that I did not mention anything about time. So the problem about this was the foundation. This is how we can measure or value our satisfaction from consumption of goods back in the 1950s. And it is a cornerstone in microeconomic theory until today. However, there is a problem with it. The problem is that the preference relation, according to the theorem, which is very rigorous and concrete according to those axioms, the preference relation is static. What do you mean by that? It means if you as a consumer always like y to y prime, alternative y to alternative y prime, then this will never change. You will always have a static preference. No matter whatever the situation, whatever the context, y will always be strictly preferred to y prime. That's what the classical theory is telling us. The problem, however, in the literature, and there are everywhere, from philosophy, psychology, ecology, from finance, many empirical paper gave us explanation that this is not the case. Humans are perceived to have different preferences in different contexts or different states of nature. What do you mean by that? So, for example, if I change the context around you, your preference order will change. There was a study done by two psychologists, I think. What they did is that they took some students and they transferred them from one campus to another. And they were noticing the behavior of those students. So their normal daily activities and their preference changed because of the change in context around them. You used to have your breakfast in a certain way because, for example, in the old campus, you had a coffee shop on campus. So you used to wake up in the morning, get your coffee, and read the paper. That was your behavior before. But when you moved to a new campus, there was no coffee shop around you, so you had to change your behavior. You're no longer having coffee and reading the paper outside. Maybe you're doing something else. So your preference changed according to the change of context. That was proof or evidence to show that humans perceive or humans' behavior is changing from one state to another. There was also evidence from psychology. I'm going to share something with you by Tversky and Kahneman, which is a paper in 1986, and both of them got the Nobel Prize in economics, although they are psychologists because of this contribution. So what they did is that they showed us that the way that we frame the problem to you can change your choice. So it's called the framing or editing. So what I can do is that it's called behavioral bias. What I can do is that I can frame a problem to you guys, and I can influence or affect your choice. So your choice in state S before the framing will be different than your choice after the framing. This is called, again, we call that behavioral bias. So let me give you an example here. So suppose there is currently an outbreak of a disease. It's actually happened. I did this in 2013. I was teaching at University of Waterloo, so this was just an example that I made up. Ironically, there is currently actually 2020. We have an outbreak of a disease. But anyways, so I'm going to frame you a problem, and I will discuss your expectation. I will show you that after framing this problem, you might end up choosing, or your preference ordering will change, or your decision will change. So suppose there is currently an outbreak of a disease that will cause 600 people to die in a specific region. Two mutually exclusive programs yielding the following results are available to you. So program 1, you have two alternatives. 190 people will be saved. That's alternative A. Or B, 600 people will be saved with a probability 1/3, and 0 will be saved with a probability 2/3. Which alternative would you choose? Now, here I'm presenting, I'm saving people. So I'm presenting you with some sort of a gain rather than a loss, right? So it turned out when people are presented or being framed this way, so that the game is being presented to them, and in this situation, the game is certain, right? So there is no probability in there. So what they do is that they would rather, if they are presented with certainty in gains, they will choose that for sure rather than taking the gamble. This will be the gamble because there is a possibility one-third of the time that 600 people will be saved, but there is also two-thirds of the time 0 people will be saved. If you are if you are a rational individual and you're using the rule of expectation in mathematics, what you would do is that you take the expected value of each alternative and then select the alternative with the highest expectation, right? If I took the expected value of the first alternative, it's 190 for sure. There is no expectation there. It's a certainty situation. If I take the expected value of alternative B, I have to take each outcome multiplied by the probability. So I will have 600 times one-third, that will give you 200, plus 0 multiplied by two-thirds, that will give you 0. So in this case, the expected value of alternative B is 200. However, would you rather take the gamble? If you are rational investor, or sorry, rational consumer in this case, sorry, if you are a rational consumer making a decision, then obviously you should choose B. However, the way I framed it to you might affect your decision because I presented you with a gain and there is certainty in this gain, so you might be tempted to save 190 people for sure. Now, let's see the second alternative. If I presented you with a loss, now you have in program number 2, there are 2 alternatives. Alternative C, 400 people will die for sure. So now you have certainty in the loss. And there is a gamble here. The gamble is that there is a possibility that 0 people will die with a probability 1/3, or 600, all of them will die with a probability 2/3. Which one would you choose? Again, when people are presented with a gamble or loss, sorry, they would rather take the gamble because if you take, again, the rule of expectation, the expected value of alternative C is 400. The expected value of alternative B would be 0 times 1/3 plus 600 times 2/3, which is 400. So they both have the same expectation, but I would rather take the gamble. So if you combine a rational investor decision regarding program 1 and 2, and compare it to an irrational investor's decision, you will see that there is a discrepancy. So if you choose as a rational irrational investor, or if you are if your decision is being influenced by this framing bias, then you would choose A and D. Basically, this will yield 190 people saved and 400 are dead. However, if you're choosing rationally, then you're going to choose B and C. So 200 will be saved and 400 will be dead. So again, rational here is better than being irrational. However, we see the irrational behavior of individual as a result of this framing bias. So there are lots of evidence. I'm going to go back to this slide here. So lots of evidence, again, from philosophy, psychology, ecology, is that people are, when presented in different situations, there is behavioral bias, there is cognitive factors, even changing the context can affect your decision. So what is the verdict is that there is a major flaw of the choice theory. The choice theory is telling you that there is a choice, and a static choice that doesn't change. But in reality, you can have different preference ordering in different situations, and that's the main problem of the consumer choice theory. Here's an example. I'm assuming 2 states, S and S prime, and I'm taking the set L of choice to be 2-dimensional just to keep it simple. X1 will be the 2 goods that I have. X1 is your own car, and X2 will be public transportation. So the bundle Y, which consists of X1 and X2, 1 and 0, means that you are using your car. I'm assuming that here is the activity is that you're transportation from, or you're moving from point A to point B. Bundle Y prime, or the alternative Y prime, X1 and X2, 0, 1, means that you are using public transport rather than your car. And S would be a sunny day, S prime would be a rainy day. Now, suppose that it's a sunny day. State S is achieved. then according to, you have a preference, and your preference is such that you prefer to drive over taking public transportation. So this means that y is strictly preferred to y prime. And by de Bruce theorem, this sign here means if and only if, so this means that you have two implications. So this implies that, and this implies that, two directions. So if y is preferred to y prime, you like to drive or take your own car rather than public transport, then this implies that there exists a utility function, that's by the Bruce theorem, and this function is such that the amount of satisfaction that you obtain from this alternative is strictly greater than the amount of satisfaction that you obtain from taking the bus, for example. However, if state S prime is realized, then you have a rainy day, your preference is completely reversed. It's the opposite. You don't want to drive in the rain. You don't like that. It's a preference, right? So your situation has reversed. In that case, there is another preference relation, another symbol. So y prime is strictly preferred to y according to another preference ordering. Remember, you are still doing this on the set L. So here you have two different ordering, one according to that, and the other according to this other relation. So it's the opposite, actually. So in this case, y prime is strictly preferred to y, and you would rather take that public transportation rather than taking your car. And again, by the Bruce theorem, there exists another in different situation. Yeah, hello?
Oh, sorry, Hany, you just disconnected for a moment, but you're back.
Oh,
All
okay.
good.
All right.
Please
Oh,
continue.
all good. Okay. Okay. So according to this, it means that you on the same set, you have two different preference ordering. I'm just trying to show you something here. So you have two different preference ordering on the same set of preference, and those orders are reversed. Now here, this is what I want to show you. So on the same set, one time you prefer y to y prime, you have a specific order here, and here the order is reversed. It is impossible to have two different orders on the same set mathematically. So this is a problem, and that's why in choice theory you can either go with this or you can go with that. The same individual could not have multiple preference ordering on the same set. This is the problem that we were trying to solve for since 1954, and I came up with a solution. And the solution was to extend this set by adding a time dimension. And when we add the time dimension, over that dimension, we can actually, I showed that there is a way that you can have multiple preference ordering of different situation or different states over time. So the solution is to simply extend the choice theory by adding a new dimension, which is the time dimension. But we have to, if we add the time dimension, then we have to look at consumption or utility from the activity itself, rather than consuming goods only. So utility is not going to be a function of y only, it will be a function of y and t. So now I'm looking at the transportation, for example, the commuting activity. I'm not talking about the amount of satisfaction that you get from driving the car. I am talking about the amount of satisfaction that you get from driving the car itself, plus the time that you spend, the duration time of the activity. So that's how we model things. So that's how we add the time dimension. If you did that, this is the paper that I published. It's mean variance time and extension of Markovitz mean variance portfolio theory. Basically, I applied this idea of adding the time dimension to a portfolio of stocks and in finance. And what I did is that I showed, if you consider constructing a portfolio as an activity that consists of a bundle of, instead of goods, monetary alternatives, and the duration time of your portfolio, or the trading duration time, then you can solve this problem. You can be irrational and rational in different situations. So this paper can explain the behavior, the rational and irrational behavior of investors if there are different situations in the market. So for example, this paper actually can explain what happened to the financial market after the COVID-19 recent event. If you assume state S to be pre the pandemic and S prime to be post-pandemic state, then according to the extension, if you consider the construction of a portfolio as an activity, then the same investor will behave differently before and after. Overreaction to financial news will prompt investor to revise and rebalance their portfolio quickly. And if the herding behavior, if every investor is doing the same thing, then you will see the whole financial market will collapse. So anyways, that's one way of applying this idea of adding time dimension. So what we do is that we consider utility from activities, not goods. And an activity is by definition a combination of a bundle of goods on the set of choice L and a duration time on the set T. T is a set of different time dimensions. So that's how we consider the activities. Running is an activity, as I said before. Watching a play, constructing a portfolio, working is an activity. There are different types of activity. You have routine activities that you do every day. There's also new activities, and there is leisure activities. There is also institutional activities. So work is considered an activity, an institutional activity that is governed by a specific number of hours, for example. Leisure activities are different. Sometimes there are routine, or sometimes there are boredom activity as well. So those different types, and your satisfaction and your behavior will vary according to the activity type. The idea of adding time doesn't only solve our problem, but it actually has it has a relation to, or it is related to the way that we perceive things. Different executions of the same activity or past experience, it turned out that they are recorded and stored in our brain so that they can easily be retrieved when a decision has to be made. So there is in neuroscience and in psychology, there is research on how we perceive time and how we store time in our brain. So if you do the activity in different ways, you usually store the experience itself is also it's stored in your brain around the so-called judgment time or a perception time. So there is evidence from psychology, as I said, in neuroscience. They demonstrated that humans are capable of perceiving, recording, and sorting past experiences. How they are doing that? Using the so-called judgment time, which I am denoting by I denoted by tau. So this judgment time is your perception, or your which is something that you can store or calculate or have a sense of in your brain. Let me give you an example. So if for instance, let's talk about the commuting activity. How many times did you commute to work? You commute to work every day, assuming before the recent events, of course. And there are different situations, right? So for example, if you're taking the car and it's a sunny day, probably it will take you around 10-12 minutes. This is your judgment time of it's the time most likely, or the expectation of the duration of the activity. And if it's a rainy day, or it's a different state of nature from your previous experiences, because you've been executing this activity on a regular basis, it's a habitual activity, then maybe it will take you, because it's raining, maybe it will take you 20 or 25 minutes. So in that case, there is a different judgment time. So what I'm trying to say here is that this judgment time is something that we have a sense of, and it is recorded in our brain. And around this judgment time, usually we're going to make an optimal decision. So an activity, the judgment time also is affected by the state of nature. Every state is tied to a particular judgment time. So we call tau, or this judgment time, is state contingent. So what I assumed, or in my theory, I proposed that given a specific state, individual will choose an optimal time, t, optimal duration time, in a neighborhood of a judgment time tau. So if you take the judgment time tau and you take a small number, small epsilon, then the optimal actual duration of your activity will be either in a basically an open set. It's half open and half closed. And the reason it's half open and half closed is because I want those sets to be distinct. So you can have so many, every set is an experience or a state, and you can have so many of them. what you do is that you will make a choice within this narrow or this small interval. So tau minus epsilon and tau plus epsilon is your local interval contingent on the realization of a particular state. And here is the this is the idea, or this is my extension. So the way to see this, assume again, I'm going to assume that this is the set of choice. So if we are talking about choice theory without time, this doesn't exist. This dimension here doesn't exist. So you can think about this as your plane. This is x1 and x2. I'm assuming it's a two-dimensional plane, just for simplicity, so that we can visualize it. And it has an alternative, right? So you can have ordering over L. The problem, as I said, if you have L if you have a specific relation over L, and you have another one, your ordering here will be different than there. And you can't have two different ordering on the same set. But now, if you added the time duration, this is the time dimension, I can elevate several planes in the third dimension. I can elevate them up. So now I have this plane, and I have this plane, another plane. This plane is basically the set L according to a specific, where the order on it is according to a specific relation. And on this plane, we have another ordering relation. So this is basically, remember the example here, y is strictly preferred to y prime. So driving the car is preferred to taking public transportation. On this set, taking public transportation is strictly preferred to driving the car. This set, however, is realized when state S, when the state of nature is S. And this set will be achieved when it's S prime. So that's a sunny day, rainy day. And as I said, the perception time or your judgment time is state contingent. So once you have a sunny day, there is in your brain a judgment time, let's say 15 minutes. Within the 15 minutes, plus or minus a small epsilon, you will have an optimal choice here. So this will be your decision and your ordering of goods and optimal time if state S happens. If state S prime happens, though, it's a rainy day, in your mind you have a different judgment time for it. So let's say it's 25 minutes. There will be another set of choices and another decision. Long story short, what I did is that I showed that there is a presentation, utility representation, that takes U from this particular set to the real line. This function is U prime. And there is another presentation that takes U, the same individual, from this set to the real line. This function is U. And then I showed that there is a way for the same individual to move from here to there. So now we have a map. What you can do is that you can move across states, which means the same individual can have multiple preference ordering over different sets according on the timeline. So that's exactly my extension. If you don't have this timeline, all those sets will basically coincide together and you will end up back on the floor here. And if you are back on this floor, you cannot have two different ordering at the same time. So this floor is simply the choice theory. And if you go to the adding the dimension is it's the time dimension that I added, and it allows you to have different ordering. Same individual could have different ordering on the same set. That's basically the idea of my recent contribution. I applied this to finance, the portfolio theory in particular. And what I'm thinking about is to basically take this and apply it to what's happening right now. Instead of having a sunny day and a rainy day, we have pre-pandemic and post-pandemic states. And what I want to do is to model our behavior or our activities, various activities that we used to do in state S, and how we are changing this to state S prime. How the activity is executed in a different way post-pandemic. Anyways, this is the utility function that I showed. So basically, this is the transportation map. It's a function. It has a specific. I showed that this function exists and it is unique. It has a specific definition. It has an upper bound and a lower bound, and it's basically will give you the optimal utility of the time or the duration of your activity. So this is the amount of satisfaction that you receive from executing an activity over a specific time, and this time will be in the neighborhood of your judgment time tau. So that's the actual duration. I also showed that this time, this is the optimal duration time. So the optimal duration time of your activity is a function of different type of uncertainty. One, it's a function of your expectation, your judgment time, that 10, 12 minutes, depending on the state. So this is a state contingent. This could be short-term or long-term. Basically, it could be something well, long duration or short duration, according to your expectation. Again, and this depends on the state as well. So this is also depending on the state, whether it's S or S prime. So it's state contingent. Gamma here is a measure of news intensity. So this measure basically traces the effect of the news, or whether it's financial news, major event, whether it's framing or behavioral bias, any factor affecting the duration of the activity itself and your decision, of course. There are many ways to define gamma. I'm defining it as a function of factors. So if we are applying this theorem to model the amount, or to model our satisfaction and hence decisions post-pandemic or pre-pandemic states, then we can define gamma to be a bunch of a linear function of a bunch of factors. One of those factors could be the news, it could be other macroeconomic factors, could be whatever that we, of course, it's related to the activity. So whatever factors that affect a specific activity in that sense. So gamma captured the news intensity. And the little c here, the parameter c, it's actually the slope of the slope, the rate of decay of this function. So you see, this is the amount, the utility from the duration of the activity, and this is the over time. You see that it's increasing at a slower rate. So some functions, the rate of decay of this utility is governed by the parameter c. If c is large, it means that the function will approach the maximum quickly. If c is small, the function will go approach the maximum slowly. How large C is depends on the activity type. Some activities are habitual activities, so in that case you don't derive really, or you get to the maximum satisfaction quickly. And some activity like leisure activity that you enjoy, then you get to the maximum satisfaction slowly, which means that you're going to spend more time on it. And some activities are guided by institutions, so in that case, C will be determined, or the time is going to be fixed. So what I'm telling you here is that we can reparameterize the function the way we like, depending on the type of the activity. So this can be done, and it is easy to measure. At the end of the day, you can measure the amount of satisfaction from this activity using this function with minor parameterization, depending on the type of the activity as well. So back to this optimal duration time. Your optimal duration depends on the expectation of, or the judgment time, the news intensity, and basically the parameter C. In finance, we call it overreaction to financial news. For any other activity, rather not a financial activity, it's called it depends on the type. So it's an activity type parameter. As I said, depends whether the activity is leisure or habitual activity or even novel activity. And here's the idea: small c and large c. Basically, how fast you reach the maximum utility depends on c. Thank you. I have a question. I have a message, so I'm just going to read this. If you add a fixed or variable cost to the activity, does this alter perception or perception over time? I.e. having dinner out activity cost versus the running activity zero cost example. Yes, so cost is a parameter that you use when you model production. What we are doing here is from the consumption side. So basically, it's a consumer choice theory. So think about it from the demand side rather than the supply side. But what you can do is that if you go to this function, see that lower bound here? That is the minimum amount of satisfaction from goods. that, so for example, your activity here, you're having dinner out with your friends. So this activity consists of a number of goods, which is basically the dinner table, well, if you're dining out in a restaurant, all the physical goods that you have, plus the duration of the activity, right? The amount of satisfaction from the goods is M, the little M there. This is the minimum amount of satisfaction that you have from just consuming the goods of this activity, not the time. So this is at time 0, which means the activity didn't start yet. You can own this stuff, of course, if you're dining at home, so you own those goods. If you don't own them, M could be 0, right? So the cost basically is the cost of those goods to you. So that could be measured or reflected in this lower bound. So it's not a cost anymore, it's just the value of owning the goods, the physical goods, without executing the activity. Once you start dining, now the time starts going 1, 2, 3, 4, and so on. So what will happen is that your satisfaction will start increasing at diminishing rate until it reaches a maximum. And this maximum, by the way, will be in the neighborhood of tau. Tau here is the judgment time. So you know that when you go out, usually it's an hour and a half. So within, your satisfaction will peak within an hour and a half, and then you're going to leave the restaurant, right? Of course, if it's a new activity or if it's your best friends and you're going out and you're having fun, this could be more or less. Again, it depends on this judgment time. So this is the minimum amount, and that's how the satisfaction is being measured. It is very powerful in the sense that you can apply to any activity. It doesn't matter what the activity is. So commuting is an activity. Dining out is an activity. Doing groceries is an activity. What we are doing right now is an activity. So I know that this is actually predetermined because I know that I have 1 hour, right? So my judgment time for this presentation is 1 hour. And what I'm trying to do is that I'm trying to make it so interesting for you guys so that your satisfaction will peak around this 1 hour neighborhood, all right? What will be the M in this case? The M will be the minimum amount of satisfaction from the physical good that I use to execute this activity. My laptop, whatever other goods, the table that I'm, or the desk, the chair, and all that stuff. Okay. Anyway, thank you for the question. I hope this is clear. So what I want to do, as I said, is the question is how to use my theory, my extension theorem, to explain and measure the effect of COVID-19 on our daily activity. So back to the first question that I started, that the motivation of this discussion, I said that think of an activity that you used to do in a certain way, and now you're doing it in a completely different way. And how can we measure that? If I can measure the amount of satisfaction pre and post pandemic, I can show that the utility is decreasing, which means that you are worse off. So basically, this is inefficient. It's a negative effect. If the amount of satisfaction pre and post the pandemic is increasing, so it means that we are actually doing this activity better than before. So there are positive and negative implications of the pandemic in different fields. What I want to do is that I want to look at different activities in different, again, economics, finance, and different sectors, and see the effect of this change in states. So I'm going to assume, the model will assume 2 states. And I'm going to go back to the same picture again here. So I'm going to assume 2 states, state S and state S prime. And I'm going to see a preference order in state S and different preference order and different decision in state S prime. And I can have 2 different functions, U and U prime. And the neat thing about this is that, remember the Bruce theorem at the beginning, De Bruce showed that there is a utility function, but this function is not unique. He showed that the function exists, but the function is not unique. In my extension, I showed that the function actually exists, the big U, this utility function, this function, it exists and it's unique. You see, I actually derived a specific definition for it. And that's the neat way about this theorem, or my extension, because once you have a unique definition, it can give you a specific value of the amount of satisfaction from any activity whatsoever. But you have to consider the activity as a combination of goods and the duration time. So not the uniqueness of the function is what shows you that a same individual can have different preference ordering over different states or different sets over time. I hope that I tried my best to use less technical definition. Thank you guys. Thank you, Hassan, for your comment. I really appreciate it. So anyways, I'm going to leave the discussion. I'm going to give you the floor right now if you have any questions. And I hope that this was clear enough. So yeah, if you have any question, please go ahead. Okay, I'm going to read Hassan's question first. I would like to question the application of decision theories to model individual behavior before and after the pandemic. Decision theories in general assume free will decisions. So variables around the decision, the problem can be modeled. Do individuals have the free will to choose in a pandemic? There are other environmental factors that drive individual decisions. Well, yes, you do have free will to choose because on this set, you can have a different order. Of course, sometimes because of the pandemic, some of the alternative will not be available to you, but you are free to choose. I mean, if there is a restriction, if it's a rainy day and you don't have a car, then you don't have a choice. But you will have a preference relation regardless. If some of those alternatives are not available to you due to external event, then yes, you can rule it out and then you don't have a choice, but you still have an order, even if because one alternative has to yield higher satisfaction from another. I hope that I answered this question. I had another question from Rob. What about the role of memory and nostalgia? We will never be pre-COVID-19 again. How do we account for our past utility? Well, Rob, we can be, well, that's the thing. So if you go back to this, this picture here, I know that in this example, I'm assuming that you are having a state S and S prime. In state S, you drive your car, and here you like public transportation. But you can still you can still move from one state to another, right? So this mapping exists. Now, in the pre-pandemic state, we can assume that you have it's a two-phase model. So this is the pre and this is the post, and you can assume that you're going to stay in this post state. We don't know whether we're going to go back or not, but there might be a possibility to go back. It's the map still available mathematically, but it might not be it might not be feasible in reality. So it doesn't really matter, but assume if you can calculate the amount of satisfaction or your utility pre and post, then you can figure out whether you're better off or worse off. And if you are worse off, then you can figure out a way to make it better off. So how can we improve, even if you're going to stay in state S prime, how can we improve it so that we can increase our utility or increase our satisfaction? There is also another question. You had the time equation earlier, 2y equal to, this is Moira. You had the time equation earlier, 2y is equal to t1 all the way to tn. No, y was equal to x1 all the way to xn. So y is a bundle of goods. It's not a bundle of time. Y is just a combination. It's a vector of goods, x1, x2. So y is the state S, the plane L, which is the choice field. It's a combination of goods. When you add the time to it, then you are combining the vector of goods plus the duration time. Okay, good. Any other questions, guys? All right, so I wrote a paper that can explain the change in the financial market, the drastic changes that happened in the financial market after the pandemic using this theorem, and I showed that irrational investors following this news ended up revising their portfolio earlier, and this contributed to increasing the systematic risk and added or causing financial markets to crash, or basically all the trends were going down. And I showed that rational investors making different choices would be better off with long-term investment strategies rather than short-term investment strategies. So again, this is something that we can also explain using this two different states and two different realities. Deb wants some volunteers to measure our activity satisfaction pre and post pandemic. Yes. Thank you. We can. You can measure anything this way. It's the more I think about it, there are different applications. Not only in finance, you can apply it to different situations. And the good thing is that you can include the news. Basically, this is the external shock that happened that affect your activity in this definition. So this is actually an empirical way of tracing the effect of exogenous factors on our daily activities. So your F1, F2, all the way until Fn are factors, could be macroeconomic factor, news factors, whatever it is, overreactions, irrationality, any of this stuff is being captured by those factors. And then you can find a proxy of external shocks. And as you can see from this equation, you can model your optimal duration of the activity as a function of a bunch of uncertainty. You can trace the demand side to the supply side that way. So this could be, again, international factors, could be other external shocks from different sectors as well. Thank you very much, Deb. I appreciate it. Sean, how about decisions that are not dichotomous, still an order of preference with multiple preferences? What if those options are very extensive? What to do this evening? Yeah, it's a good decision. So what we assume here implicitly is that we are assuming that we are executing one activity at a time, so that your 24 hours is divided into a bunch of activities, and you are maximizing utility from each. Some of those are routine, some of those are institutional, and some of those are leisure activities. There is also the possibility, by the way, to save time. So what you can do is that you can combine two activities together, so you can free some time to do something else. That will increase your satisfaction. So basically what you can do is that this is one of the things that we can benefit from. Now we don't have to wake up in the morning and get dressed and be stuck in traffic for 10-15 minutes to go to your work and then waste half an hour on doing all that. You can just wake up in the morning, get your cup of coffee, sit down and start working. It saves you half an hour. So this could be, again, comparing pre and post pandemic. I'm not saying it's always going to be positive, but that would be one of the efficiency of doing the activities online rather than actually physically be there. So that could be the time saving. There is also a way to substitute between goods and time, because we have two dimensions. We have the plane of goods and we have the time dimension. So what we can do is that there is a marginal rate of substitution between goods and duration, and that will give you the value of an activity into the monetary value of it. So it can actually value, or you can measure the value of the execution of different activities that way. So, however, to trace it properly, the implicit assumption is one activity at a time. We can still move this from a static, I would say, discrete measure to a continuous way. But I have to change the model a little bit so that you can allow those neighborhoods to not to be distinct. So far I have a left open, closed, right closed sets like that. So they are distinct, and every set, this is tau, this is tau prime, they are distinct. If I open them, totally open, now you can do this. The two sets basically can overlap. And if the two sets overlap, then this whole thing will become not one activity at a time, but it will be continuous, and you can execute two activities at the same time. But at the very least, we can still measure something under this simplifying assumption. Of course, the more you complicate the model, the more you can get from it. But for now, it's just basically a simple way to model the change. Good, awesome. Any other questions? All right, fantastic. Thank you, guys. I think
Hany, for that. Vanessa again, and thank you to everyone who joined us. And I think we're really looking forward to seeing how your work evolves. Thank you so much for sharing it with us.
Thanks, I appreciate it. So if any of you guys are interested in sharing your thoughts, or if you're having an idea how to apply this model to different activities, I would stay for maybe 10-15 minutes after the session. I would be in the room just to discuss your ideas or to brainstorm. So feel free to stay if you wanna chat. Thank you.
Thank you.